Traumatic thoracic injuries often result in morbidity and mortality. One of the main reasons for this are rib fractures that lead to mechanical instability of the chest wall. The ribs can be surgically stabilized to treat such instabilities. In order to test the influence of rib fractures and their treatment, the aim of the study was to develop a biomechanical setup with which the kinematics of the ribs can be simulated during respiration. Compared to other test setups, it should include the negative intrathoracic pressure. The biomechanical test setup consisted of a basic frame, the cable system for simulating the negative pressure, an axial testing machine, and a high-resolution camera system. To generate the negative pressure, weights were attached to O-rings via the cable system, which were sewn to the ribs from the inside. Screws with reflective markers were attached to the ribs, which can be tracked by the camera system. The axial testing machine is used to pull on the sternum so that the movement corresponds to the natural breathing in order to simulate the respiratory states, expiration, inspiration, and maximum inspiration. Tests are performed in the following conditions: native, flayed chest, and surgical stabilization of rib fractures. The parameters that were analyzed were the system stiffness resulting from the force and distance of the testing machine, as well as the paradoxical motion of the ribs recorded by the camera system. The system stiffness increases in all breathing states, with increasing negative pressure and with deeper breathing, while it is lower in the flayed chest condition compared to the other conditions. During the flayed chest condition, an extremely high paradoxical motion also occurs, although this can only be seen with a negative pressure. It can therefore be said that the negative intrathoracic pressure has a major influence when it comes to the biomechanical testing of rib fractures and their osteosynthesis. In summary, the outcome of the study is that a biomechanical test setup with negative intrathoracic pressure produces more clinically relevant outcome.